surprised that I didn't. But I was like, there are like a lot of people talking about it, but not a single one of them was like, I'm gonna try. And also, the presidential election year, battleground states, I think they would put up a candidate, so, something, just to try to get the Republicans out to go for like Trump or something, right? North Charlotte, kind of crazy. I'll be here next semester. So by Huntersville, Davidson. I've heard of it. I don't know if it's there, honestly.
Dude, so I don't even know where any of my house are. Do you remember how my socks got squished? I don't know where it went. I don't remember if I just like left it here. One of my friends was like, very excited. First graduated. Oh, he did? I've been trying to get some we have a couple centers that mentioned in Florida, and I want to go and tell Dr. Eric Cooper that we want to play conservation. I tried to test my high school.
Charlotte, if you look at just the city,
Will you see it again? I've never gotten this.
twice that. So the reason for this is that Charlotte has absorbed a lot of stuff. A lot of back in the race, there was a unit of white men. I like them. Something even bigger, but kind of. I have so many white men like me recently that they didn't have CA. Okay, that's too strong. You should have a CA. Something like Charlotte, when yeah, that's weird. Because we have to send your PA, and I would meet with my PA like every Friday, and send him my paper, and like all that. Something like Atlanta. Yeah, I had a representation on Friday.
Oh, your slides aren't opening.
Oh,
It says file up there.
gotcha.
Plugging a 404 error.
I'm pushing it. I think it's
Beautiful, that's what I thought.
change that to a C.
Oh, to a C.
Perfect.
There you go.
All right. All right, let's get started, folks. It's a beautiful day for some programming. Some of you may have noticed that slides are currently issuing a 404, meaning the page is not found. I had a typo in the link. If you change the V in practive to practice to a C, that link will work. I've also just pushed up those changes, so the website should be updated very shortly. Today, we're just going to be practicing some of the object-oriented concepts we introduced on Tuesday. So hopefully everybody has made it through Tuesday's material, and we'll be jumping right into it with some practice tracing. And the first diagram that we'll be looking at involves a class and some attributes, some methods, constructor. Let me change over to my laptop here, as well as some usage of that. And before I review what it is we're looking at here, I'm going to encourage you to go ahead and try tracing this in a diagram and applying what we learned on Tuesday today. So we'll spend a few minutes on this, and then we'll talk through and review what's going on here, as well as trace through it together. 2 more minutes, and then we'll review this one together. If you complete this, you can go ahead and start a file in lessons named point.py and get this code going. We'll be doing that just after this diagram. All right. If you didn't quite make it through this one, that's okay. But for the purposes of getting some review going here, I'm going to start talking about what we're seeing here, and then we'll diagram it together. So we're seeing a class, and sorry, my PowerPoint's being a little strange. It's not letting me write, so I'm going to try opening up another tool. And classes define data types. Here we're defining a data type for the idea of a point in, say, a 2D Cartesian coordinate plane. And that class definition is everything you see from lines 4 all the way through line 16, right? So that's all of this. And classes are made up of a few different kinds of components. So hopefully you're able to recognize X and Y are attributes. And we can think of attributes a lot like bundled variables that are sort of grouped together that make up the idea of a point. Whenever we're working with a point, every point is going to have an X and a Y attribute associated with it, and they're both floating points in this example. Well, when we go to construct a new point, we think about a class kind of like a blueprint, where when you have a blueprint for a house, you can't walk around inside of that blueprint, but you can use that blueprint to go and construct actual houses, and the class is the equivalent of the blueprint. It's not until we actually go construct a point that we can actually work with one. And the constructor is this, what looks like a function, but it's got this special name in it, right? And some of the properties of a constructor are that it has this parameter self, which we'll talk about how that gets set up again as a review in just a moment. Its return type is strange, that we never specify the return type of a constructor because it's always going to return a reference to the type of object that we're constructing, in this case a point. Similarly, we see a method, scale by, and methods give our objects extra capabilities. And so we're going to be able to scale a point by some factor, which is just multiplying its x and its y by the same amount. And if you've taken a class that's involved some vector math, you've seen a similar concept there. Otherwise, it's just multiplication. Right? So when we're defining classes, we're introducing new data types, and those data types are made up of primarily two things: what attributes or what data is stored inside of objects of this type, as well as what can we do with an object once we have one. And of course, we need to be able to construct one, and that's what the first part of this example is all about. So now what I'm going to do is switch slides here and give myself a little bit more space. So I apologize for the size of this, but let's talk through this. How does this come together? So in our stack, we've got globals as usual. And when we see a class definition, in this case point, we set up a reference to the class definition, right? And just keep track of the line numbers like we do with a function. Classes are different from functions in that we're specifying multiple things like the attributes, constructor, and methods. But just like a function, we're not actually evaluating what's inside of this class until we go and make use of it later. So we're saying we've got the blueprint for a point, and we don't actually start making use of that until line 19. On line 19, we see an assignment statement. And that assignment statement on its right-hand side has what looks like a function call, but when we go and we look at what actually is point bound to, notice it's not bound to a function, it's bound to a class. And when you call a function that's bound to a class, that kicks off a special process called construction, and we're going to construct a new point object. So whenever this happens, the very first thing you can go ahead and do is set up, a point object on your heap and give it the attributes that it has declared in it, x and y. And in this case, these attributes are not initialized yet, right? But we know we've got these attributes available, and we're good to go, right? Next, what's very important is we have to figure out, hey, does this class actually define a constructor? So we look inside the class definition for something named init, surrounded by two double underscores, and yes, it does. So then we need to check, do the arguments correspond to the parameters that are defined? So we have 1.0 and 2.0, those are floats, those correspond to x and y. And what we know about this self parameter is that it's automatically set up on our behalf, and we'll talk about that in just a moment. So this does check out. This is a valid constructor call. When we go to add the frame for the constructor call, what we'll do is set up the name of the class, point, followed by a hash symbol, and then the name of the constructor, which is just init, right? And the return address works just like a function. It's line 19. That's where we're going to go back to after we've constructed our object. We have this self parameter, which we need to set up. We have an x parameter and a y parameter, right? Now, self is automatically, by Python, going to refer to this new point object that we're constructing. This is happening behind the scenes, right? So somewhere between Python saying, oh, we're calling point, which is this class, it's set up this point object on the heap that we can work with, and then when we define this constructor, it's taking self and assigning a reference to that object to self, so that inside of this constructor, we can now set up the attributes of this object that we're working with. Okay? But before we jump into the actual implementation, we have to establish x and y. Those are 1.0 and 2.0. All right? So we've established our parameters, and we're ready to jump into this constructor. And we see that the first thing that happens is an assignment statement. We're saying take the current value of x. And for that, we look in our current frame. X's value is 1.0. And we are assigning it to self.x, right? So whenever you see the dot operator, you know that you're following a reference, right? So self dot, we look at self, dot says follow this arrow, and then x in this point object is now going to be assigned 1.0, right? Which was that parameter's value. Same idea with y. We take y's value in the frame, that's 2.0. It was passed in as a parameter. And we assign that to self.y. Self.y is now going to be 2.0. Now, constructors are different from methods in two key ways. First, we don't call them directly, right? You never write the word underscore underscore init when we go to use this constructor. Python is doing that automatically for us. But importantly, when we reach the end of constructor, we don't see a return statement, but constructors do return. What they return is a reference to the object that we're constructing, right? So the return value here is a reference to the same thing that self referred to, the same object itself referred to. It's as if there's an implicit return self statement here, right? And this is something you've just got to remember. The reason why we don't write this is because every constructor does this, and it would be very redundant. This is the whole point of a constructor, right? The purpose of having this in our code is to make it easier for us to establish new objects of this type and have all of their attributes that we care about fully initialized. And so here, the attributes we cared about were x and y. Those are now initialized to be 1 and 2. This object is set up. It's ready for us to be used. So we've returned, and we're returning that back to line 19. And what are we doing with that reference? Well, we're assigning in P0 in globals a reference to that point object, right? So that was all that happened on line 19. Let me pause here and see if there are any questions on what we've done so far. And we don't have mics today, so I'll just have to repeat questions. Yep, question over here.
The name PO.
Yep.
Where would we put that at in the memory diagram?
Yep, so that's this P0 here. I didn't put a slash through it, but it would go in globals. So we were returning back to the globals frame, and that's where P0 would be. Good question. All right. So on this very next line, we see a method call, P0.scale_by, and then an argument. So how do we identify a method call versus just a plain old function call? Well, you'll notice that what looks like a function call is following a dot, and that's how you know you're working with a method call. That's the key distinction. And what's happening is we're calling this method specifically on P0. So we're saying, hey, P0 object, I want to call your scale by method with an argument of 2.0. So how do we process a method call? It's got a few more steps than a function call. So first, what we need to do is determine whether or not this is a valid method call. In order to do that, we have to look at what is the reference we're using here. So that's P0. So we look back in globals. That's where we're working right now. This frame is returned. P0 is bound to something of type point. So OK, we look in the point class and ask it, does it have a scale by method defined? And sure enough, it does. And then we test, do the arguments align? So 2.0 is an argument that corresponds to this factor parameter. So that works out. And self, once again, is automatically set up on our behalf. And we'll talk about that in just a moment when we go to set it up. In this case, we're not doing anything. We're not using the return value of this method call in any way. So it's OK that this returns none. So our return type checks out too. This is a valid method call. Let's jump into the frame for it. So I'm going to set up a point and then use the hash symbol, scale by. And we'll see in another example later today why it's important that we use the class name as part of this labeling for our frame. The preview is that we can have multiple classes that all have the same method name, and that's OK. But in this case, we just have one class, point, scale by. The return address here is line 20. And we have our parameters self and factor to set up. Right? So once again, self is automatically established on our behalf. And how is it established? Where does self come from? When you look at that method call, when we see P0.scaleBy, P0 is what self will be. So P0 is a reference to this point with xy12. So self is also going to be a reference to this point with xy12. Right? So when you call a method, the self parameter is established by looking at what object or what reference did you call that method on. Right? And factor is just going to be this very first argument here, 2.0. Now, there's one other thing I want to say about this self parameter, which is you'll notice that unlike the other parameters, it doesn't have a type associated with it, right? We're not writing self colon and then a type. And that's, again, because the language knows that we're always working with a typed point. Like if we did type this variable, this parameter, it would be self colon point. But that's redundant because it's always going to be that within this class. And so we don't do that in Python. Right? So we jump into the scale by method, and we see that we are using the multiplication reassignment operator with factor, and this is our current frame. So factor is 2.0. And if we're using multiplication reassignment, that's as if we're saying, OK, take self.x is 1.0, and multiply it by 2.0. Right? And we know that that's going to be 2.0. And we're reassigning that back to self.x. Right? So x is no longer 1.0. It's now 2.0. Same idea with the second line where we're multiplying the y attribute of this point object by factor and reassigning it to itself. So 2.0 times 2.0 we know is 4.0, and we update that y attribute. This is a function, or I should say a method, that does not have a return statement, and that's OK because it returns none, so our return value is going to be none, and this program would complete. And before I take questions on this method call, I want to point out that this method call is a certain kind of method that it's kind of hinted in this comment here that mutates the object that we call it on. And that's kind of a strange sounding word, mutation. All that means is changes, right? So this method is changing the attributes x and y as part of that method call. And so if we were to have printed p0.x after this method call, we would have seen that That's now going to be from global's frame, p0.x would be 2.0, p0.y would be 4.0. Right? So we've changed that object as part of a method call. In the example we're about to do together in code, we'll look at a way of implementing a scale method that doesn't mutate the object that it's called on and instead returns a copy of it or a new object for us to work with. And there are trade-offs in these two designs, but I just want to point that out before we get into the next example. Questions on this method call? Or this example? Yep.
You said the return type was none in terms of this. That's how it worked. Say if we were given a statement where it's like, how would we identify the return type based off the last line? Like line 20.
So the question is, how would we know what the statement p0.scaleBy, what its type is, if we were to try and assign it to a variable or something like that? So in the Python language, it's kind of funny. If you were to print this, the result, the return value of this out, if we were to print this out, it would just print none. And it would print literally none. And none is actually a value in Python. But you would typically never, like you would have an error if you tried to say, A is some type, we don't know what that type is assigned p0.scaleBy, right? And I'm not even going to finish writing this out, p0.scaleBy. This would only work if we wrote none here, but it would be kind of silly too, because there's no real value in none, and the purpose of this method is really just to modify or mutate that object that it was called on. Any other questions on this example? All right. So what we're going to do next, actually, is jump into VS Code, continuing on from this example. And I'm going to pull this up and see if I can make it as large as possible. What I'd like you to try doing is going ahead and in your lessons directory, setting up a file named point.py and replicating this example that we started with, tracing. So this gets us to the point of what we just traced together. And then we're going to modify this in another few minutes. So I'll give you a few minutes to get up to speed here, and we'll come back once you're ready to go. 2 more minutes on this, and then we'll work through it together. I should note that when we're working on a follow-along in class, if for some reason you run into errors because of a minor syntax thing, don't stress. We'll be talking through all the details together. If you want to test whether you've got everything, you can try printing p0, f string of, say, p0.x, comma, p0.y, and you should see 2 and 4, like we just traced together. If you run this and you get something else or you have an error, try not to stress. We'll be talking through this conceptually. All right, so I'm seeing fewer heads going up and down, back and forth, getting this down. Let me just talk about what we're about to do before we get into it. So here we have this method scale by, and it is mutating the object that we call it on, right? We're changing the x and the y parameters, or the x and the y attributes of the point object that we call this method on. What we're about to look at is trying to create what we call a pure function, or one that does not mutate the object that it's called on. And the reason why we care about these things is because it turns out it's harder to reason through programs that make use of this type of method than it is the types of programs that make more use of the kind that we're about to write, one that does not mutate the object that the method was called on. You'll need to know how to understand and reason through both because both are very common, but I just want to sort of use this as an example to point out 2 different ways of implementing the same idea and some of the trade-offs. So let's add a new method beneath the scale by method. And we're just going to call this one scale. It's going to always take a self parameter as the first parameter. That's just every method is going to have that property in Python. And a factor as well, which is also going to be a float. This time around, though, rather than returning none, which implies that, OK, well, if this method had any value, and it doesn't return anything, then it must have changed the object that we worked with. This time around, we're going to return a point object, or reference to a point. And you're going to see some red underlines. And we'll talk about why in just a moment and how to fix that in just a moment. But for now, I'm going to ignore it. And go ahead and add a comment that is, say, pure method that does not mutate the point. Right? So what's going on with this error that we see here? Well, if we were to hover it, I would see that point is not defined. And that seems kind of weird. Like, we know that we're defining the point class. We know we should be able to write a method that returns a point. Well, the way that we're using these types in Python, such as saying factor colon float, the way that we're saying the type of this parameter is a float, this return type is a point. This is what we call annotations in Python. And they're actually a relatively new feature in Python. We're in Python 3.9 or 3.10 today. These came on in Python 3.6. So it's only been in the most recent years that these annotations have existed. And the functionality that we need for this method to be able to return a point is actually something that hasn't landed in the current version of Python yet. It's in a future version of Python that's coming. But we can use it today through a really weird import. So at the very top, on line 2, just beneath the doc comment, add this import. From _future, import annotations. And that will resolve this error. Now, I'm going to tell you, it's kind of embarrassing that Python has to do this in 2021. It's the world we live in. Any other programming language that makes use of types in this way, this isn't the case. But in a future version of Python, this will be fully supported. For now, we have to say, hey, Python, do something special here, and that resolves that issue. All right, so that's really just an accidental complexity. That's not giving us anything. You shouldn't have to do this. I'm sorry that you do on behalf of the Python language, but it is what it is. So let's actually go and implement this method now. I'm going to break down what we're trying to do here into a few steps. So let's set up some local variables. So an x local variable that's a float. and is assigned self.x multiplied by factor, and a y local variable that's also a float that's assigned self.y times the factor. And then we want to set up the point that is going to have the scaled x and y attributes. So I'm going to set up a variable named scaled point. That is of type point. And we're going to construct a new point. So notice we're calling the point constructor with x and y as the initial attribute values, or the initial arguments for constructing that point. And then we will return scaled point. Okay. So I've broken this down into a number of lines. We could have actually done this all in one very concise step, but I think it's instructive to see them broken out, what exactly is going on. And so when we call this method, we would have some local variables established. We're just sort of setting up some scratch variables for x and y, and then we set up this brand new point. And notice we're calling that point constructor. So that means that we're going to have a second point that lives in the heap. We're not modifying anything about the self variable. So notice there's no reassignment to self's attributes, so we're not mutating or changing the object this method is called on in any way. Right? So how do we make use of this? Well, notice it does have a different signature than our scale by method. Scale by is going to return none, so we can just call it and then later make use of the point that we called that on. Scale is going to return to us a new point, so we better set up a new variable to hold that. Right? So in the example usage down here, what I'm going to do is set up another object that is P1, which is a point, and it's going to be P0 dot scale by, or sorry, scale 2.0. Right? And we can print the f string of that, so P1 dot x and P1 dot y. Oops, I need to surround that in curly braces. All right. So notice that when we called this method on P0, what we're doing is we're actually returning a new reference to a point. So P1 would be pointing to a brand new point that is what P0 was previously, scaled once again by 2.0. Oops. All right, so if we were trying to run this, what we would expect to see is, well, we started P0 at 1, 2. We scaled it by 2, so then we would expect 2, 4 to print out here. And then we set up this brand new point object, P1, as the result of calling this other implementation of the idea of scaling. And we see that that's going to be 4 and 8 as its resulting values. Right? So I'm going to try running this real quick. So Python -m lessons.point. And sure enough, the outputs we expect. So if we were to try and diagram this, which I'm not going to carry out today, but I can post a video of this if it would be helpful, and I think it would be worth coming into tutoring if you want some experience with diagramming a method like this. What we would see is, in this method call, P0.scale, we would be setting up, like this constructor is ultimately going to mean that we've got 2 points on our heap, right? We would have 1 point that we had previously mutated such that its x was 2.0 and its y was 4.0. And that in globals would ultimately have been assigned to P0. And then P1 would have been assigned a reference to a brand new point that's a result of this scale method, whose x would have been 4.0 and y 8.0. Right? And the reason for that was because we were scaling the already scaled P0. So these two methods demonstrate two different means for achieving the same thing, and they have some trade-offs. Right? The first method, the one that we looked at first, is modifying the object that it was called on. Right? So notice we're saying self.y, we're updating our x attribute to be whatever the new value is, and same with the y attribute. And so this call was mutating or changing the object we called it on. As opposed to a second implementation where rather than changing anything about the object we're currently working on, we're going to set up a brand new object assign it some new values and give that new object back to you. When in doubt, if you can write methods that do that, they're easier to reason about because you're not making changes that you don't really understand or that you have to go look at how does this method work in order to know how it changed your object, right? So this is the difference between the first method is what we would call a mutable function or method, and the second one is immutable, or pure is another way of thinking about it. Questions on what we're seeing here? All right. So next, we're going to take a look at one other diagram. And this one involves multiple classes. Oops. So here we've got a code listing where there are two classes defined. They share some characteristics in common. As you're thinking about tracing through this one with your neighbor, I would encourage you to try and identify where's the constructor, where's the attributes, which are the methods, what are the method calls, and be very careful in how you process these things. As I said, the reason why we keep track of the class name in addition to the constructor or method name in our frames when we trace a program like this is because in this example, there's some ambiguity. So both of these classes have constructors, and both of them have a method named speak. So go ahead and take a few minutes on this, and then we'll come back and talk through it together. You do have TAs around if you want to ask questions. Compare your notes with your neighbor. Another few minutes on this. This one's a longer one. Two more minutes on this example, and we'll walk through it together. Thirty more seconds. All right. Let's talk through this example together and work through it slowly. So we've got two classes here. This is the first diagram where we've seen two classes defined. It turns out when your programs are running, there's tons of classes that already pre-exist in the Python programming language, such as list and dictionary and some others that are predefined for us. And I should note that those classes that we've been using, like list and dictionary, they have methods too, right? When you called list.pop or dictionary.pop, those were methods that are built into those classes, and it's okay for two classes to have methods of the same name. It's okay for two classes to have constructors. And let's think about what the implications are as we're diagramming through this. So when our program begins, of course, we've got, I'm not going to write stack and heap here because I'm going to be limited on space. I'm probably going to have to erase some things as we get through this because there's 5 total frames, and globals is our first. And in globals, we see the definition of a dog is the class declared on lines 1 through 8, right? And again, when we reach a class definition, it's the blueprint for when we need to go work with objects of type dog. This is what a dog is made up of, a name attribute, and what it can do. It can speak, and we can construct it with a name, right? Similarly, class, the cat class has a very similar design, right? And this is really for the purposes of just illustrating some concepts in this silly little code listing. This is, you would expect dog and cats to have much more interesting attributes and capabilities than what we've got here. But for demonstration purposes, we're just showing off two classes that are very similar to one another, but ultimately have some different behaviors. All right, so no surprises yet. On line 21, we reach our first interesting line. And when you reach an assignment statement, it's totally fine if you want to go ahead and set up space for, say, the variable name Fido. You know that it's ultimately going to be a reference to a cat. I like to focus on what's on the right-hand side first, because that's what the programming language is going to do. So you're not going to see me write Fido first. I know that it's coming. We're going to come back to that. But really, the first thing we need to do is figure out what is going to be returned by this, what looks like a function call. But it's not a function call, right? Because we look at what is cat. Cat is bound to a class, so that means we're constructing a new cat object. And as soon as you reach a constructor call, you can go ahead and set up space for it on the heap. So cat is going to have a name attribute. But that name attribute is not yet assigned any initial value. After you've set up some space for this object that you're constructing, you need to look in your class and see, does this class define a constructor? And yes, cat does have a constructor. So we should check, is this a valid constructor definition and call? Well, we've got one parameter besides self, which is name, and that's a string. We're passing an argument Cleo, the string, to this name. So that seems to check out. And the definition is otherwise valid. So let's go ahead and set up a frame for this. And so my frame is going to be cat hashtag underscore underscore init. Right? So this is our constructor frame. The return address is going to be line 21. We're going to have a self parameter to set up and a name parameter. Right? So self is automatically, as part of the construction process, assigned a reference to this object that we went ahead and carved out some space for on the heap. And name is going to be assigned Cleo. Right? That was the argument we gave. Right? So the string Cleo is the argument being passed to the name parameter. And we jump into this constructor, and this is, you're going to come to find that most constructors follow this exact same pattern, where we give some parameters that are some of the attribute values, and we take those attribute values and assign them straight, or those parameters and assign them straight to our attributes. And that's what's happening here. We're saying take name, which is Cleo, and assign it to self.name. So that just sets up this attribute. Cleo is assigned to the attribute name on the object we're constructing. Once again, we reach the end of a constructor, so what do? We return self. So our return value is this reference to the object we just constructed. Where are we sending that return value back to? We're sending it back to line 21. Right? So this call to the cat constructor resulted in a reference to this cat object. So back up in globals, that's when we can say, okay, Fido is being assigned a reference to this object we just constructed of type cat. And you'll probably notice there was something kind of silly going on in this example. Fido is often used and associated with dogs, but here we've associated with a cat. And the purpose of this is to illustrate that a variable name is completely unrelated to, say, the attributes of the object that it might refer to. Right? So the name Fido could have been X, it could have been Y, it could have been a cat, whatever we wanted it to be. And that's separate from the name attribute of this cat object. Right? They're two very different ideas. All right. Similarly, we go through the same process on the next line. We're on line 22. We are reaching another what looks like a function call. But when we look in our globals, we see, oh no, that's not a function, that's a class. So we need to set up a dog object on our heap. We know that immediately without looking at anything else. And it also has a name attribute. And it's uninitialized to begin with, right? We're looking up at the dog class now. So once we've established this space on the heap for this object that we're constructing, we need to look inside of the class and see, does it define a constructor? And sure enough, it does. It's on lines 4 through 5. So we check, does this all map? And yeah, it's got a name parameter. The name Loki will be assigned to this name parameter. And it's got, yeah, it looks, everything checks out. It's exactly the same as cat's constructor, just by coincidence of this example. So let's go ahead and set up a frame for this. So this is gonna be dog, hashtag underscore init. And you'll notice that now we see why it's sort of important to keep track of which class we're constructing in our frames, because we can construct one of many different classes. So this tells us we're using dog's constructor. And the return address here is going to be where we called this constructor, which was line 22. We know that self is automatically going to be established as a reference to this object that we're constructing, this dog object. And name, we're passing in Loki. It's a Loki dog. All right, so we're ready to jump into that constructor. And it does exactly the same thing as cat. It's very boring. We take name, which is Loki, and assign it to self.name. So we're initializing this name attribute of our object to be Loki. And we reach the end of that constructor, and our return value is going to be a reference to this object we just constructed, right? Constructors follow this pattern. It's very strange. In this class, almost every constructor you'll see will be just like this. We pass in some parameters that are the attributes we want to initialize. We initialize them, and then we're done. They do exist, and there are reasons to have more complex and more nuanced constructors than this. But for our purposes, we're really just setting up an object so that it's ready to be used. And that's the point of a constructor. So we're returning that back to line 22, where that constructor was called, and Leo is now going to be assigned a reference to, and I'm going to use a different color here. I'm going to use pink for Leo because I'm crossing over some arrows here, a reference to that dog we just constructed. All right. Before I get to lines 24 and 25, let me pause here and ask questions about constructors, constructing an object. All right. So where this example is going to get really interesting are these method calls, right? Because that's where we have to be very careful and follow some more special rules. Because I'm working on a slide that's about to run out of space, what I'm going to do is I'm going to obscure or occlude these two frames for the constructor. So you should leave yours on your diagram. I would too. And I'm just going to make a note that the init calls happened. But for the purposes of this diagram and being able to fit it all onto my screen, I'm just going to simplify this down and make a note here of constructors hidden. All right, so you would leave yours on your diagram. But notice that back up in globals, we've actually got all of the important information. Fido is a variable that refers to a cat object. Leo refers to a dog object. And we're ready to go on line 24. So on line 24, we reach this method call, fido.speak. Again, when you see what looks like a function call, but just before it, the dot, and then something that's a reference, you know it's a method call. And this kicks off a set of steps that we have to be careful with, right? So, okay, we see what is Fido. Fido is bound to a cat object, right? So we need to know whether or not the cat class defines a speak method. And so we go and we look in the cat definition. Yeah, sure enough, this is the cat's speak method. So we know that this is the method that we're going to evaluate, right? So we have to ask, is this a valid method call? Well, there's no arguments here, and that corresponds to there being no parameters after self. So that's valid. The next thing we check is the return type. The return type of this is a string. It's giving us back a string, and we're trying to print that string out. That's fine. So we've got a valid method call. Let's set up a frame for it. So we prefix cat is the class that we're calling this method on, and we're calling the speak method on that cat object. Right? The return address is line 24. And here's where things get interesting. Right? What is self? Well, we called this method on Fido. Fido, and let me see if I can get like a green color here to show up. Fido is this arrow here, right? So self is going to also be a reference to that same object, right? And Python is automatically setting up that reference for you. And this is what object-oriented programming and method calls are all about. We're automatically saying, okay, self is going to be a reference to the object this method was called on. This method was called on this cat object or reference to it. So self is automatically going to be established as that. And we're ready to jump in. So we jump into this function, and all it's doing is returning a string. So we can go ahead and set up our return value. And the return value here is the string self.name. Right? So we look in our current frame, and self is bound to the cat whose name is Cleo. So self.name evaluates to Cleo. And colon meow. Right? We're returning that string back to line 24. And so our output here begins with Cleo meow. Right? Any questions on this method call? Yep.
My question is, why didn't you call speak first after cat, like after the init method? Why didn't you just go on to speak first?
Good question. So the question here was, why wasn't this print statement immediately following this construction? And the most honest answer is just to show that we can have these two objects set up, and later on we can call their methods in whatever order we want. So there's not a real good reason, and we could have written it that way. But what's important to recognize is, we could have imagined a lot of other things happening in this space, like lots of other interesting things in our program going on. And later on, we realize, maybe we're making a game and we pressed a button that should have whatever animal we're working with called its speak method. And we need to know which method do we actually look up. And so the example that we're looking at here is really trying to emphasize this process. How do you know, we've got two speak methods, and if you kind of ignore this for right now, looking at just these method calls, you have no idea what speak method is going to be called, right? In order to know that, we have to look in memory. So for example, when we reach line 25 and we see leo.speak, we have to look in our globals frame and see, okay, Leo, what's Leo? Leo is bound to a dog. So that means we need to look in the dog class to see if it has a speak method defined on it. And sure enough, it does, right? And so that's going to be the speak method we're referring to there. Right? So to continue this example, we would once again check to see is this a valid method call. And there's no arguments here. There's no parameters that corresponds to. Self is automatic. Self is going to be whatever Leo refers to. So we set up a dog speak frame here. Right, and the return address is line 25. And self is once again going to be established to be whatever Leo was, right? So we said Leo.speak. Leo is this dog. So when we go to process this method, self is also going to refer to that same dog object, right? There are no other parameters to set up, so we jump in, and on line 8, we once again see that this is just going to return a value. But notice this implementation is slightly different than cat. It's saying woof rather than meow. So our return value is, we plug in self.name. Well, self is a reference to this dog whose name is Loki, so that's what's going to cause Loki to populate here, colon woof, right? We return that back to line 25, and that results in a print, that value is printed out directly. So we would have Loki woof. These calls could have happened in any order, right? We could have called them multiple times. The point of this example really is trying to emphasize that you have to be careful when you're evaluating a method call to know what type of object that method is being called on, because the same method name can be defined in multiple classes. So the only way you know is by figuring out, well, what type of object did I call this on? Fido's type was cat, Leo's type was dog, and that's kind of confusing, right? These are poorly chosen variable names, intentionally for this code listing. But the same would be true, if you had a list The way a list is going to pop a value is different from the way a dictionary is going to pop a value. Those are both methods with the same name. Questions on this example? Or anything about constructors, method calls, object-oriented programming in general? So the last couple of announcements that I want to make are about things that are currently out. We've got, again, on the course website, the current project, or current exercise is a project. And it's a fun one. It's one where we're not using object-oriented concepts yet. We're still using the concepts that we were looking at just before we got started this week. And early in the semester, you took a survey. And that survey included information about majors and interests in computer science, things like that. And this project is come up with a hypothesis and do some analysis of the data from that survey, which included 500 some responses. And it's a chance to apply what we learned and do some real data analysis. That's all we've got for today. We'll end early here, and we'll see you all asynchronously on Tuesday for some more object-oriented, and then back here next Thursday.
Do you know when the project will be released on Gradescope?
Oh.
'Cause I didn't see it on mine yet.
Yeah, let me look. Let me ask Kaki. Let me just check the earlier section and make sure we didn't. Just one sec. We're figuring this out in real time. I think she's going to get up today.
Okay,
Yeah.
sounds good.
Cool,
Thanks.
thanks.